Limit is y goes to 0 of the sine of 2y minus the sine of 3y divided by 6y. First thing we're going to do is try plugging a 0 in for each of the y's. That will give us sine of 2 times 0 minus the sine of 3 times 0 all over 6 times 0. Sine of 2 times 0 is 0 minus sine of 3 times 0 is 0 divided by 6 times 0, which is 0. The sine of 0 is 0. So we have 0 minus 0 over 0. 0 minus 0 is 0. We have the 0 over 0 indeterminate form. We will need to rework this. Since we have the 0 over 0 resulting from trig functions together with power functions, we will want to make use of the identity. Limit as theta goes to 0 of the sine of theta over theta equals to 1. Now for our function we have sine in the numerator subtracting another sign in the numerator. So we're going to want to actually break these apart into separated fractions that are subtracting each other over that common denominator. So we can write it as sine of 2y over 6y minus the sine of 3y over 6y. And now what we're going to do is work with each of those individually. Each of them are 0 over 0, and each of them can turn into the identity. To make the identity happen, it starts with isolating the sine function. So we're going to have sine of 2y isolated over something. It's in the numerator, so keep it in the numerator, and then the 6y, the remainder, will be put in the other fraction. It's in the denominator. And we're going to be doing the same thing with the second fraction that's being subtracted. We're going to isolate the sign. It's in the numerator. And then the remaining functions can be put in another fraction. 6y will be in the denominator. Now what we want to do is phase match. So we're going to go to the sine of 2y, that's sine with a phase of 2y in the numerator. We need to put a 2y in the denominator. And then to compensate for that 2y in the denominator, we're going to put a 2y in the numerator of the other fraction. Those 2y's would cancel back out, so we still have the original. Same thing with the next set. We have sine of phase 3y in the numerator. We're going to put a 3y in the denominator, and then a 3y in the numerator of the other fraction to compensate for it. And that way we've produced the identity for the sine functions. Now, in the other fractions, we can reduce as needed. The other fraction in the first set would have the y's cancel, and then the 2 and the 6 would cancel to a 1 and a 3. And in the second set and fraction, the y's would cancel, and the 3 and 6 would cancel to a 1 and a 2. So we can now rewrite what we have left. Limit as y goes to 0 of sine of 2y divided by 2y times 1 over 3 minus sine of 3y over 3y times 1 over 2. We still have 0 over 0, but we have the identities now because we phase matched them. This will go to a 1. This will go to a 1. So that we no longer have the 0 over 0 indeterminate form, we can plug a 0 in for any remaining y's, which there aren't any remaining y's, so we would have 1 times 1/3 minus 1 times 1/2. 1 times anything is that same thing, so we will have 1/3 minus 1/2. Probably a good idea to put these over a common denominator, so looks like it'll be 2 times 3 or 6. I'll multiply the 1 over 3 times 2 over 2, and the 1 over 2 times 3 over 3, giving me 2 over 6 minus 3 over 6, combining 2 minus 3, negative 1 over 6.